Bismillahirrahmanirrahim. Welcome to the Mashriq University Engineering College for academic years, Electronics and Communication Engineering Batch 4. Course Microelectronic Technology. Topics of the lecture: Introduction to the Microelectronics Technology courses. Microelectronics Technology Introduction lecture contains. Let us to describe the contents of this lecture. In this lecture, we are discuss about electronic system domain of work and applicational area. Also, we are discuss about microelectronic design objective, which gains from design side. The next topic is technological trends due to the microelectronics technology. Also, we are discuss about Semiconductor Industry Association (SIA) abbreviation that organize the industrial applications of semiconductor fabrication. The next topic we are discuss about design task of design in case of symbol and approach of design. Also, we are mention some guides about mixed technology for electronics and the challenges and possible solution for problem associated with the microelectronic fabrication and design. Now in this slide we are some cases and case study for electronic systems in applicational area, which gains the overall electronic fabrications and design for many types of devices and systems, such as microcomputer design and generation, home device such as washing machine, play device, PlayStation games, and other types of mobile phones, and car automations, which are gains and controlled by microelectronics or microchip that control every state and behaviors in each types. Now let us to consider about microelectronic design objective. Briefly, basic principle of microelectronic design objective is design for electronic system support for system that providing to the user of the system or system itself. Design for electronic automations and automatic execution, such as robotic system and partial or full automations. Electronic system design at high level of abstraction for many applications, such as biomedical domains or other engineering factors used for design electronics. Also, the brief objectives of microelectronics objective design is variety application and science, gaining for use benefit and helpful of design electronics for some. Now let us to consider continuously microelectronic design objectives from the previous slide. Also, the main design objective is implementation and optimization algorithm, such as use algorithm for security purpose and optimization for implementation. For example, microelectronic system or ATM system device. Another objective is design for test and design for testability techniques. This side oriented to the that system can also designed to be tested many times during operation or during design test itself. Another design objective is hardware description or description language (HDL) that use language for abstraction to support design steps and use software criteria to support hardware design. Another objective is usage of VHDL in design or sciences process to support good design features and automations of the micro. Now let us to consider about the technological trend that facing the electronic design process and fabrication of microelectronics. We are concerning about the technological trends due to the microelectronics. For example, the number of transistors per chip. This is the greatest trends facing the design philosophy and design process, which is for chip design, the number of transistors per each chip. Another trend is a clock frequency that also providing the speed of chip. The third one is the memory capacity, the capacity memory within system itself for support purpose and operation cycle. Also, the performance and performance measure is take place to technological trends. The measure that used to assess the system and performance measure for. Here is a two-dimension graph demonstrate the technological trend in factor of very important technical citation, Moore's law, that facing the relations between the increase of years and the number of transistor increment. So, number of transistor per chip would double every 1.5 years, and also clock frequency will double every 2 years. These checkpoints demonstrate the relations to implementation this real data and plotting it in 2 dimensions. The horizontal citation provides the number of transistors and the horizontal for years and vertical for transistor numbers. Also, these tables demonstrate the sample or real data for Semiconductor Industry Association (SIA). The short table demonstrates the technical factor. For example, for each year, stop from 2002 up to 2014. Actually demonstrate the feature size, the logic per transistor per centimeter square, the transistor chip, chip frequency, clock frequency, chip size, wiring level, and power supply in voltage or watt or battery lives. These are the factors of how the design change from years to years and how it can be improving inside of, for example, the battery powers change from 2 up to 3.7, and number of transistor or feature size change from value to indicates the association of design and improvement inside of performance. In this slide we have discussed about the main design task in many points. Let us to start from system specification. So the design task oriented to the system specification exactly for functionalities, function of the system, and requirements for these types of system. Another design task is the hardware and software trade-off. Also the relation between hardware and software associated to each system. Another part of design task is architecture solutions and explorations. So many types can be used. Connection with the optimization and implementation, that how architecture selection being implemented and it can be optimized for good design task and good functionalities. Another system design task is testing and design for testability. So system will be designed and support the to be testable every time we need that. For example, testing for measuring device or micro device or biomedical device and instrumentation, or in technical car solutions. Another point for design task is analysis and simulation. Simulation factors use software criteria to analytical system operation and scenario. Another one for design task is verifications and validation, to be valid and verifying the operations step by step or overall system functionalities. The tech point also used for task oriented for design management, storage of design data. So system capable to design plenty of data or storage media providing for system task. Last point is cooperations between tools and design flow. Tools used for design and design flow, step by step construction of design from start up to the end of design, and conversion the idea into real-time system. Now let us do brief design objectives. The unit cost, that indicates the cost of manufacturing each copy of the system, prototyping and each copy. NRE denotes the non-regressing engineering cost. For example, the one time cost of designing the system, one copy of the system total cost. Size indicates the physical space required by the system, which take place in size. For example, this oriented point to the electronic micro system or nano system for support nano technology, minimum size requirement. Another design objective is performance, how system work, and the performance or performance measure. For example, the execution times or the throughput of the system. Now let us to continue the design objectives. First of one is the power, which indicates the amount of power consumed by the system. This factor also a very good point of design objective, effect in battery life. For example, the mobile phones, which battery can be work many times without need for charging. Another design objectives is testability. System should be changed to testable, or the essential way of testing through the system to make sure that it works correctly. Also, test value should be logic value 0 or 1 to indicate the correct operation or failure operation. Flexibility indicates the ability to change the functionality functions of the system without incurring heavy NRE cost due to the previous design objective course. Another design objective is correctness and safety. Safety means that how it can be operate without cause damage to the surrounding system or to the surrounded operations or human's body in case of biomedical devices or manufacture for electronic design or radiations of electronic or other factors. Now this slide demonstrates clearly use of mixed technology for electronics fabrication. For example, use logical design and analog types or DRAM for mixed purpose embedded in a single chip logic or analog or digital design for DRAM blocks. Also embedded advancement technology block used to embed between technology to providing a good system in case of technology use. For example, FPG, flash, RF and microwave. Also the beyond electronics used for example MEMS, microelectronics mechanical system or optical elements. So the microelectronic design use all these techniques are technology for mixed purpose and providing good microchip for heavy duty and good support for system design. Now in last point, let us to consider about the design or the challenges facing the microelectronics in contact with the system complexity. So to main aims is to increasing functionalities and diversity, increasing the performance and good features for the system. The stringent design requirements, the requirements for design, for example, main points to be considered: low cost of design and low power conceptions, high reliability, testability, and flexibility, as mentioned before. Also, the technological changings for the cost efficient implementation for deep submissions effectiveness, and issue related to the process variations, the variation between process to process, and the related issue used for this design in contact with for sample of electronics. Now let us to end the lecture with the possible solutions for the microelectronics technology that phase or 3-point indicators sideway. The 1 point is a powerful design methodology and tools, the selection of good methodologies and selection of best tools results for design powerful. Also, another point is advantage and advanced architectures modularity. Use modular types for advanced architecture, and dividing system into a part or module for good design. The last point is extensive design reuse another paradigm or modularity for new generations. So the design paradigm shift is used, and this is the summary for possible solution. Thank you.